Every year, over 250 million turkeys are raised and processed across the United States, feeding a nation where turkey has become not only a reliable source of protein, but a cultural icon. Thanksgiving alone accounts for nearly 46 million turkeys consumed in a single week, highlighting the deep-rooted connection between this bird and American tradition. From family feasts to holiday dinners, the turkey holds a place of pride on millions of tables. Yet, behind every perfectly roasted bird is a massive, highly engineered system designed to operate year-round, with demand peaking in the final months of the year. This is the story of one of the most efficient and sophisticated food supply chains in the world. In recent years, across various U.S. states, free-range turkey farming has gained significant momentum. These operations offer a glimpse into more ethical and sustainable approaches to poultry farming. On these farms, turkeys are allowed to roam freely in open pastures, basking in natural sunlight and feeding on grass, insects, and grains. This access to open air and natural forage contributes to stronger immune systems, reducing the need for antibiotics. In turn, the meat from free-range turkeys tends to be more flavorful and nutritious, attracting health-conscious consumers willing to pay a premium for quality and transparency. While free-range farms represent a small but growing niche in the overall market, they offer a contrast to industrial farming and appeal to consumers focused on sustainability and animal welfare at the foundation of any large-scale turkey production system is a scientifically managed breeding process. Commercial turkey farms rely on carefully selected breeding stock developed over decades for traits such as rapid growth, large breast muscles, and efficient feed conversion. A single female turkey or hen can lay between 100 to 120 eggs during a breeding season. These eggs are collected through automated nest systems, featuring sloped floors that gently roll the eggs into cushioned trays. This reduces the chances of breakage and contamination by up to 95% compared to traditional hand collection. The collected eggs are then cleaned, sorted, and moved to advanced incubation facilities, where they spend 28 days in strictly controlled environments with optimal temperature and humidity. Once hatched, the baby turkeys, known as poults, are evaluated for health. Healthy poults are vaccinated against diseases such as Newcastle disease and infectious bronchitis before being transferred to warm, brooding houses, where they spend their first few weeks under heating lamps set at -34 degrees Celsius. This early environment is critical for their survival and growth. As they grow stronger, poults transition into the grower stage between 4 and 6 weeks of age. At this point, they weigh around 1.5 to 2 kilograms. To ensure their comfort and prevent issues like feather pecking or stress, stocking density is adjusted to allow more space per bird, typically 4 to 5 birds per square meter. State-of-the-art ventilation systems maintain air quality by removing excess heat, humidity, and ammonia, which can negatively impact bird health. Nutrition during this phase is also carefully managed. Feed, containing 22% to 24% crude protein, is supplied to support skeletal and muscular development. Each feed mix is customized based on the age and health of the birds, ensuring optimal growth. Farmers also monitor water intake and sanitation, using filtration and disinfection systems to prevent the spread of disease. By the time turkeys reach the finishing stage, they have already gone through weeks of intensive management. In this final phase, turkeys are raised in expansive facilities that house anywhere from 5,000 to 50,000 birds. Automated feeding systems precisely deliver balanced rations, and feed efficiency becomes the primary focus. Over its lifetime, a turkey will consume an average of 92 kilograms of feed, an impressive investment in energy and nutrition to achieve market weight. After 16 to 20 weeks, turkeys reach their target weight, about 13 to 15 pounds for hens, and up to 30 pounds for toms. At this point, they are carefully loaded into transport trucks equipped with climate controls and biosecurity protocols. The birds are delivered to modern slaughterhouses where humane handling and sanitation are the top priorities. Upon arrival, the turkeys are hung on an automated line by their legs or wings. Stunning methods, either electrical or controlled atmosphere stunning, are used to render them unconscious quickly and humanely. Next, the turkeys move through a series of stations for bleeding, scalding, and defeathering. Rubber plucker. Fingers remove feathers quickly and gently, minimizing damage to the carcass. Inside the processing facility, every step is closely monitored. Temperature, humidity, and cleanliness are maintained according to USDA standards. After defeathering, turkeys are eviscerated, a process that removes internal organs, using a combination of precision robotics and trained workers. The organs are inspected, and anything deemed unsuitable is discarded. The cleaned carcasses are then chilled rapidly to temperatures below 4 degrees Celsius to inhibit bacterial growth. Large plants can process 2,000 to 3,000 turkeys per hour, and as many as 50,000 turkeys per day, especially during the pre-Thanksgiving rush. Some of the largest U.S. processing plants use AI-driven quality control systems to detect bruises, bone fractures, or contamination in real time. Once chilled, the birds enter the portioning phase. Here, sophisticated machinery breaks down each bird into its marketable components. A leg processor separates the thigh from the drumstick. Then, a secondary machine further divides these parts to meet varied consumer demands. Drumsticks are packaged whole, while thigh meat is often deboned and used in prepared meals, sliced turkey products, or ground meat. Breast meat is carefully extracted in large, unbroken pieces and sold as fillets or diced for value-added processing. Wings are trimmed, portioned, and sent to be seasoned or marinated. Advanced X-ray systems help guide machines to avoid bones and reduce product loss. Nothing goes to waste. Turkey fat is rendered into oils for pet food or biofuel. Bones and offal are processed into animal feed or fertilizer. Even the feathers are repurposed hydrolyzed into feather meal, a protein-rich ingredient in livestock diets or compost. Byproducts are tracked, measured, and monetized, ensuring sustainability across the chain. After butchering products are vacuum sealed and labeled with production dates, batch numbers, USDA inspection codes, and refrigeration instructions. Fresh products are sent to regional distributors within 24 hours. Frozen turkeys are flash frozen at -35 degrees Celsius and stored until shipment to grocery stores across the country. Logistics ramp up weeks before Thanksgiving. Cold storage warehouses stockpile frozen birds, while fresh turkeys are distributed just in time for the holiday. Transportation companies work around the clock to move product efficiently. In many homes, meal planning begins with one critical question: where will we buy our turkey this year? As the industry looks toward the future, several trends are shaping its evolution. Consumer demand for transparency has led to new traceability technologies, such as blockchain systems that allow customers to scan a QR code and trace their turkey's journey from farm to fork. Environmental concerns are pushing companies to adopt solar energy, methane digesters, and regenerative farming practices. Researchers are also exploring alternative feeds, such as insect protein and algae, to reduce reliance on corn and soy. Even plant-based alternatives to turkey are growing in popularity, though they remain a small share of the market. The American turkey industry stands at the crossroads of tradition and innovation. It combines high-tech logistics, biology, ethics, and scale to deliver a product that's both symbolic and essential. From the moment a fertile egg is laid to the instant a turkey is carved at the dinner table. Every step is part of an intricate choreography performed by farmers, scientists, engineers, and workers. This isn't just poultry, it's a precision industry rooted in heritage and driven by progress. And that's something worth chewing on. Gone are the days when walnut harvesting relied solely on manual labor. In the past, families and seasonal workers would gather in orchards, using long poles to shake trees and picking the nuts by hand from the ground. But today, the walnut industry has undergone a remarkable technological transformation. What was once a slow, labor-intensive process has become a highly efficient, fully mechanized operation that blends agricultural expertise with modern machinery. This evolution has revolutionized how walnuts are harvested, cleaned, processed, and delivered to markets worldwide. The journey begins with the use of a highly specialized machine known as a mechanical tree shaker. This equipment is fitted with powerful hydraulic arms padded with soft rubber to avoid damaging the tree bark. These arms gently but firmly grip the trunk of each walnut tree. Once secured, the machine is activated, producing rapid vibrations between 200 and 250 shakes per minute for 5 to 10 seconds. The vibrations are strong enough to dislodge ripe walnuts from the tree branches, causing them to rain down en masse onto the orchard floor. This method ensures a fast and consistent harvest without harming the trees. After the walnuts fall to the ground, the next step is carried out by a machine known as a sweeper. This device combines soft, rotating brushes and a low-pressure air system to gently move the fallen walnuts into neat windrows, organized lines that run between rows of trees. The sweeper also separates out dry leaves, dust, and twigs, leaving only the valuable walnuts behind. On average, one sweeper can cover between 20 and 40 acres in a single day, depending on the terrain and tree spacing. This mechanical approach not only improves efficiency, but also minimizes damage to the nuts following the sweeping process. The pickup machine, or harvester, is brought in. This machine lifts the walnuts from the windrows using a conveyor system and transports them into an onboard sorting unit. Here, a centrifugal fan is used to blow away any remaining lightweight debris like dust and dry leaves. The heavier, denser walnuts continue along the conveyor belt to be collected for the next phase of processing. Precision at this stage is critical as it ensures that only clean, high-quality walnuts are sent for further treatment. Time is of the essence when it comes to processing walnuts. Once harvested, they begin to deteriorate quickly if not handled properly. To preserve their flavor and freshness, walnuts must be processed within 24 hours. That's why most orchards have primary processing facilities located nearby. At the facility, the first task is to remove the green outer husk from the walnut shell. This is done using a hulling machine that combines rotating rollers and high-pressure water jets. The rollers gently roll the nuts, loosening the husks, while the jets wash away the debris. This husk removal is vital because if left too long, it can stain the shell and affect the quality of the kernel inside. After hulling, the walnuts go through another round of cleaning and sorting. Vibrating screens help to separate them by size, while a calibrated airstream system blows away hollow or damaged nuts. This ensures that only fully intact, dense walnuts continue to the drying phase. Moisture content at this point is still very high, around 30% to 35%, which is unsuitable for storage. Therefore, the nuts are transferred to industrial drying systems where heated air circulates around them continuously. This drying process usually lasts 18 to 24 hours and reduces the internal moisture level to below 8%, which is ideal for long-term preservation. Once the walnuts are fully dried, they are cooled and then packed into large ventilated bins. These bins are transported in sealed containers to a secondary processing facility. Upon arrival, the walnuts are placed into advanced storage warehouses equipped with refrigeration and humidity control systems. The ideal storage conditions are between 0 to 5 degrees Celsius with strict moisture regulation. These controlled environments allow walnuts to retain their crisp texture, aroma, and natural kernel color for up to 12 months. It also gives producers the flexibility to ship according to seasonal demand without compromising quality. When it's time to prepare walnuts for market, they are sorted into two major categories: In-shell walnuts and shelled walnuts. The in-shell. Walnuts are first placed into a rotating drum sizer, a cylindrical device with perforated holes of varying diameters. As the drum rotates, walnuts fall through holes matching their size, effectively sorting them. After sizing, they are given a final wash using clean water and then undergo manual inspection. Workers carefully examine each nut, removing any that are cracked, misshapen, or exhibit signs of pest damage. The selected nuts whole, clean, and uniform are then packed into mesh sacks or bulk cartons for export to international markets. The process for shelled walnuts is more intricate. These nuts are initially sorted by size using a V-shaped roller system that separates them according to diameter and weight. This pre-sorting ensures consistency during the cracking phase. Next, the walnuts enter mechanical cracking machines. These machines use rotating steel cylinders to apply precisely calibrated pressure, cracking the shells while preserving the integrity of the kernel inside. Proper calibration is critical because an incorrect setting can crush the nut or leave pieces of shell embedded in the flesh after cracking. The mixture of shells and kernels is separated using airflow chambers, vibration tables, and sometimes optical sorting machines. These systems use air pressure, weight, and visual cues to differentiate between fragments of shell and edible nut meat. Despite the advanced technology, human workers are still needed for the final quality control step. They inspect the kernels by hand to remove dark, shriveled, or damaged pieces. Only golden, plump, and intact walnut halves are selected for final packaging. Packaging is done with great care to preserve freshness. The kernels are sealed in vacuum packs or nitrogen-flushed bags, both of which protect against air, moisture, and light. These methods extend the shelf life of the walnuts and ensure they arrive to consumers in perfect condition, whether they're being sold in a neighborhood, grocery store, or a luxury supermarket halfway around the world. From shaking the tree to sealing the package, the walnut's journey is a carefully orchestrated process of timing, technology, and quality control. Each step, from the orchard to the processing line, is designed to maintain the nut's natural flavor, crispness, and nutritional value. The evolution of this process reflects broader changes in agriculture and food production, where machines have taken over many of the most labor-intensive tasks, making it possible to feed millions efficiently while still maintaining traditional quality. So the next time you enjoy a handful of walnuts, whether tossed into a salad, baked into bread, or eaten straight from the pack, remember the incredible journey behind them. It's a story of vibrating trees, conveyor belts, drying tunnels, and dozens of unseen hands working behind the scenes to bring you nature's brain-shaped snack in its finest form.